Hello and good day. We are from Section 5, Group 6. Today, here we are gathered to discuss our project presentation regarding the crop yield prediction using fuzzy logic for chili plant. Okay, before we begin our presentation, let me introduce myself and my group mates. Firstly, myself, I'm Tamil Arasi, and then Harini, Katyayani, and Jevina Rani. Okay, firstly, for the introduction of our project. The deployment of a machine learning and fuzzy logic support system for crop production prediction for the chili plant is a noteworthy agricultural research project. In order to forecast crop output based on soil temperature and moisture content, this project will make use of cutting edge technology. The study centers on the chili plant, a major crop in many different cuisines, acknowledging both its economic significance and the variety of obstacles that come with growing it. One such study involved developing fuzzy logic controllers to regulate temperature and humidity in agricultural settings, which have been discussed in this project. The data utilized for analysis and growth prediction of chili plants is from the Malaysian Agriculture Research and Development Institute, which is MARDI. There are three totals of growth for chili plants, which are slow, average, and ideal, that have been inserted as the input variables for this project. Moving on to the second is the objective of our project. So, firstly, the objective of this project is to create a reliable decision support system that predicts the yield of chili plants by using machine learning and fuzzy logic in relation to soil temperature and moisture content. The initiative intends to use these technologies to give farmers quick and accurate information so that they may decide how best to manage their crops and allocate their resources. Then, secondly, to utilize external data sources to analyze crop development by applying the fuzzy logic technique. The predictive capabilities of the system will help to optimize agriculture operations, which will ultimately lead to increased crop output and economic. This intends to examine the performance of fuzzy logic for crop yield prediction for soil analysis. That's all from me, and I shall pass to my next groupmate.
Thank you, Damal. So I'll continue with the literature review. So basically, fuzzy was found by a renowned professor who is L.A. Zadeh, and he developed the notion of grade of membership, leading to the foundation of fuzzy theory. So in this case study, the fuzzy logic development actually focuses on the required moisture level and the temperature level for the chili plant. So the suitable moisture level of the soil is actually from 50% to 70% for the chili plant growth. And the temperature between 25 Celsius to 28 Celsius are ideal temperature, whereas the temperature below 10 Celsius causes it to stop growing actually. So when the temperature are above 38 Celsius, the crop is prone to fruit and blossom abortion. So that's all from me. I shall pass to my next team member.
Alright, thank you, Yani. So now I'll be continuing on the system analysis and design. So the figure here is actually shows the diagram of fuzzy logic architecture. So actually there are three stages in fuzzy logic architecture, which is the first stage is the fuzzification step, following by the fuzzy inference engine, and the last one is a defuzzification process where it is used to convert fuzzy sets into crisp output values, which is the final output of fuzzy logic system. So as we can see here, we have two input, which is relative humidity, temperature, and the output is crop growth. So the fuzzy variable here will be the relative humidity, temperature, and crop growth. The next one is the fuzzy linguistic value, where for the relative humidity we have 3, which is low, medium, and high. Temperature is also low, medium, and high. And for the crop growth is slow, average, and fast. So next slide. So this is the membership function and graph for the relative humidity. Next. Temperature. Next. And also crop growth, which I will be explained on the simulation. So next slide. Alright, so now I'm going to explain more in detail about the simulation of this project. So Yani, can you present your MATLAB?
Can see the MATLAB?
Not yet. Okay. So as we can see here, we have two inputs as I mentioned before, which is the relative humidity, temperature, and the output is will be the crop growth. So click on the relative humidity. Okay, make it bigger. Okay. Alright. For the relative humidity, input variable has three membership, which is low, medium, and high. So the input relative humidity value is actually range from 0 to 100%, where the low relative humidity has a value between 0 to 55%. For the medium, um, is 50 until 75, and lastly is high, which ranges from 70 to 100. Okay, move on to the temperature. Alright, so the temperature here is actually measured in terms of Celsius, in terms of low, optimum, and high. So the input temperature values actually range from 0 to 50. So we can see from the range here. For the low temperature has a value between 10 to 25. The medium is actually from 24 to 28, and lastly is the high temperature, which range from 27 to 40. Move on to the output. So the value of the output variable has three, which is slow, average, and fast. So the output value range from 0 to 100, where the slow growth has a value between 0 to 45%, and the next one is average, which is starts from 40 until 75, and lastly is the fast growth range, which from 70 to 100%. So that's all from me. It will be continuing by Katyayani.
Okay, thank you, Harini. So next we will look into the inference rule. So this is our finalized graph for our inference rule. So we actually have 9 rules, which are related to the relative humidity, temperature, and crop growth. So the operator used to connect two input values to get the outcome is actually n. So we have 9 inference rules. So the first inference rule will be if the relative humidity is low, the temperature is low, then the crop growth is actually slow. So the second would be if relative humidity is low and the temperature is medium, then the crop growth is average. The third will be if relative humidity is low and the temperature is high, then the crop growth is also slow. So moving into the fourth inference, which is if relative humidity is medium and the temperature is low, then the growth is actually average. And moving into the fifth, which is if relative humidity is medium and the temperature is medium, then the crop growth is fast. And the number 6 is if relative humidity is medium and the temperature is high, then the crop growth is actually average. So moving into the 7, which is if the relative humidity is high and the temperature is low, then the crop growth is actually slow. And moving on to the 8, which is if relative humidity is high and the temperature is medium, then the crop growth is actually average. And the last one, which is if relative humidity is high and the temperature is high, then the crop growth is fast. So the red line actually indicates the dephasification of the entire process. So in voice like if the relative humidity is high and the temperature is also high. So it indicates that the crop growth is actually good. We can see the red line shows here, which is actually the defalsification line. So that's all from me. I shall pass to the next presenter.
Okay, thank you, Yani. So next, we will be presenting the defalsification calculation, where it includes the calculations and the process, where we have utilized the center of area defalsification process, and this approach calculates the area under the scaled membership functions within the range of output variable. And this is the membership graph and the calculation for the center of area defalsification progress and process. And as per the slide. And the fuzzy logic system processes input values for humidity, temperature, and output, which is the crop growth. And in this case, humidity is categorized as low as per the input 50, temperature as medium, which is 25, and the crop growth as average, which is 57.5. The membership value representing the degree of belonging to this category is assumed as 0.2 based on the output for rule viewer in MATLAB using the center of area process. And we have added the support of the shaded region of the membership by multiplying it to the membership degree divided by 0.2 times 4 as per the calculation, and we have gotten a 55 as our result, which is close to the crop growth prediction from the output through our MATLAB. So that's all from me for the defalsification. Next slide, please. Okay, so for the conclusion, this study and this research actually leverages a fuzzy inference system and machine learning to predict chili plant crop production with a focus on soil temperature and moisture as the key parameters. So through fuzzy sets and linguistic variables and the Mamdani type rules, the model effectively categorizes the crop growth based on relative humidity and temperature inputs. While the results highlight the success of the system, the study recommends refining the fuzzy logic rule, incorporating additional environmental factors such as integrating IoT devices for real-time monitoring and enhanced predictive accuracy. And the developed model combining fuzzy logic and expert knowledge demonstrates the commendable accuracy and predictions in transforming imprecise agricultural data into meaningful predictions. And overall, this research represents a notable advancement in applying advanced technologies to agriculture, offering a promising approach for informed decision making and resource allocations in the field of chili plant and crop production. So that's all from me for the conclusion. Thank you.